Okay, next, moving from liquid to solid, and this is the area that we will spend a little more time on, because that is what is what we use most commonly in our applications in refractories, solid blending, and chemical processes industries. They involve solid mixing of ceramics, chemicals, fertilizers, powder detergents, and the volume of this is phenomenal. It's over a trillion kilograms of granular and powdered products that must be blended annually uh, to meet quality and performance goals. We're talking about refractories. Mixtures of many different raw materials are required for special purpose refractory products in order to achieve the desired properties of the product. So that makes solid blending extremely important for us. In terms of the classification of equipment, just like we had equipment which were axial flow, radial flow, low clearance, and high shear. In the case of solid blending equipment, we will primarily classify these equipment, as tumbler blenders or gravity blenders and convective blenders. So, at the beginning of the discussion, we looked at the blending mechanisms and we said we have diffusion blending, we have convective blending, and we have, uh, fluidization mixing. So in diffusion blending, basically there is a slow motion random movement of particles, which is used to carry out mixing. So when you have a gravity blender where you charge the raw material in a vessel and the vessel is tumbled around, you basically are doing gentle mixing by the principle of diffusion. And in tumbler blenders, you have different constructions of equipment. So there is the gravity drum blender that you have in your facility. There is a double cone blender. There is a V blender. There is an octagonal blender. It is just the geometry of the vessel. In one case it is a V shaped. In another case it is octagonal. Like it could be a drum shape or it could be a double cone shape. Then we talk about convective blenders. Now in convective blenders, the difference is that you actually have an agitator inside the vessel. So the vessel, in some cases it is a rotating vessel. In some cases it is a stationary vessel. So for example, when we talk about the pan mixer or the intensive mixer, there we have a shell or the vessel which is rotating, and we have a mixing element which is also rotating. And while it is rotating, it is generating convective flow of the material. And that is why these are called as convective blenders. Okay. So the ribbon and the paddle blender, these are commonly used convective blenders in the chemical, food, pharmaceutical industry. You have a plowshare mixer. Now a plowshare mixer in some ways is a convective blender, but it also belongs to the family of blenders which work on the principle of fluidization. So here, while the agitator is generating a convective motion, it is rotating at high speeds, and the speeds are so high that they cause fluidization of the material inside the mixer. So the solid materials get fluidized, and mixing is achieved because of fluidization of particles. So a plowshare mixer or a twin shaft paddle mixer, you are using the twin shaft paddle mixer in your plant. And so these work on the principle of convection, and they also work on the principle of fluidization. And then there is something called as silo blenders. These are blenders which are used for large volumes. I doubted whether these blenders are being used in your industry, but again, in large, where the volumes are large, silo blenders are commonly used. So tumbler blenders or gravity blenders, convective blenders, blenders working on the principle of fluidization, and silo blenders. Right. That's where you see a tumbler blender. In the top, what you see is the top right is the double cone blender, and the bottom is a V blender. So tumbler blenders function mainly by diffusion mixing. They rely on the action of gravity to cause the powder to cascade within the rotating vessel. Mixing homogeneity of up to 98% and higher can be achieved using tumbler blenders. Blending efficiency is affected by the volume of the material loaded into the blender and the speed of rotation. These blenders can be actually provided with high speed intensifier bars in case where you have some liquid addition and you want to disintegrate the agglomerates. That is possible. They are preferred for precise blend compositions. They are best suited for free flowing and non-segregating powders. The fill-in capacity of these blenders is 50 to 60% of the total volume. One thing to be remembered is any blender, say if it has a total volume, the vessel has a total volume of 1,000 liters. The volume which you can use effectively, if you want to mix well, is not going to be more than 60 to 70%. The reason is simple. For blending to take place, you need free space for the material to actually kind of mix. So in the V blenders, 50 to 60% of the gross volume is the working volume, and typically the blend times in these kind of equipment are 5 to 15 minutes. As I said, your drum mixer also falls in the category of tumbler blender or a gravity blender. What are the advantages? Easy of product charging, operation and discharging of material. The shape of the blender ensures that 100% or complete discharge of the product material is effected. This is an extremely advantageous aspect of the tumbler blender, 100% product discharge. There is hardly any particle size reduction because you don't have any moving blades or agitators inside. The absence of any shaft projection or seals in the working area of the blender, they eliminate the possibility of product contamination. This blender is easy to clean and requires minimal maintenance. So it has advantages. Anything which has advantages could also have its disadvantages, and in this case, the biggest disadvantage is that you need high headroom for installation. So there is, the volumes of these equipment will have to be limited because you have such a huge mass of body actually rotating and can have safety concerns, take a lot of space. Segregation problems occur when mixtures having a wide particle size distribution or large differences in particle densities. This is an important aspect, with particle size distribution being wide, you have limitations in using this blender. And highly cohesive materials cannot be handled in the tumbler blender since they tend to form a bridge over the blender outlet. So that's kind of the limitation of the tumbler blender. Next, we come to the convective blender, and in the convective blender, as I said, the plowshare mixer falls under a fluidization blender. You can see the simulation video of the plowshare. The material is rotated at high speeds and it gets fluidized. Okay. Now, blending in convective blenders occurs because of random movement of particles throughout the mixing vessel caused by the action of the mixing elements. So we have the horizontal ribbon blender, we have the vertical ribbon blender, we have the vertical cone screw blender, paddle blender, plowshare mixer, twin shaft paddle mixer. These are some of the convective blenders.